Hi everyone, welcome to our 10th lecture. This is going to be a shorter lecture on the development of software. Okay, so we've already studied that computers are made up of two components. There's the hardware component and the software component. Okay, and you need both to have a computer. The hardware components are the physical devices that make the computer do what it does. Okay, like that CPU. Okay, the graphics cards and so on, and they have to be manufactured by a manufacturer. So that's where the hardware comes from. There are companies like Intel, which makes the CPUs for desktops and laptops. Okay, and then there's actually another company that does the same too. It's called AMD, but they're both mostly develop CPUs. There's another company called NVIDIA. It does graphics cards and so on. Texas Instruments, you may have heard of them because they do the calculator. So if you take a calculator, which is a computer, because everything is a computer today, and you open up a calculator, you would see a motherboard there, and then there'd be the various integrated circuits welded into the motherboard. I didn't mention here, but Samsung, for instance, does phones. Okay, so that's the hardware component. It's made by these manufacturers. Okay, but where does the software come from? All right, and the software we know is an important part of the computer, because without the software the computer can't run. Like when you turn on a computer, and if it doesn't have an operating system, it just says, oh, I can't run, I don't have an operating system. Okay, I demonstrated that for you earlier. Now if it has an operating system but it doesn't have any apps, then the computer doesn't do anything for you, because the apps are the various tasks that you want the computer to do. Like even a phone, the app that does the phoning on a phone is itself an app. Imagine a phone that doesn't have an app that does phone calls. I mean, that would be kind of useless. Okay, literally everything on a phone is an app. Everything that you interact with on a phone is an app. Okay, and so that's all software, and you might want to ask the question, where does that software come from? Now, why is it important, for someone who's not a developer, not a software developer, to know where this software comes from? And that is because you're trusting an awful lot of your information to those apps. Okay. Now, imagine a browser, and what this browser does is when you put the username password to go to your bank, okay, to log into your bank, or maybe to log into Amazon.com, or you put your credit card information and that into this browser. Okay, like Firefox is a browser, or Safari on the Mac, and something like that. Okay, so you put this information into this browser. The browser is supposed to send that information to the bank, but how do you know that browser doesn't send that information at the same time to some other third party? Okay, that's stealing your information. Okay, you actually can't know that. All right, and now this should make you feel a little bit paranoid, because you're really trusting an awful lot to these apps. Okay, and as a result, you're really trusting an awful lot to these software developers. All right, and so it's important to know something about the software world, like the world in which people are doing software development. It's important to know that, so that you have some idea of like why you should trust it, what you should trust, what you shouldn't trust, and so on. Okay, so that's really what this lecture is about. All right. So I myself am a software developer, and in the process of, as I go through this lecture, I'm actually going to do a little software development example for you. Okay. Before I do that, though, we jump into software development, I have to tell you what source code is, because this is the critical thing in understanding software. Okay, so whether you're talking about an operating system or applications, human beings develop software by writing it in what's called source code. Now, what source code is it's code which looks like English. It looks a lot like English. You'll see it in just a minute. I'll write a program for you that just says hello world. Okay, and this software, it's meant for human readability, but it's also meant for the computer to run, to carry out some task. Okay, but computers don't work in English or whatever. They actually work in binary. And so the source code, which is readable by humans, isn't really directly readable by a computer. Okay, what the computer has to do before it can actually read it is has to convert that source code into what's called an executable. This is basically binary code that the computer can then actually execute. Okay, now the source code is important because humans can read it, and if I see source code for some program, I go, oh, I can see what that program is doing. The computer can't use the source code directly, but if you convert that source code into the binary code, then the computer can execute it. Okay, so this source code is basically really the human readable form of what the application does. Okay, now I know this is a little bit abstract, so I actually have a demonstration for you. Let me just demonstrate for you some source code. Okay, so what you're looking at right now, let me switch to another screen here. Let's see. Yeah, what you're looking at right now is a development environment, okay? And you don't have to learn any of what I'm telling you right now. Just, like any of the details, just like try to understand what I'm doing here, okay? So basically, I can issue commands in this environment, and it just responds to me, okay? Now that ls just tells me list all the files that are in this directory, and there are no files, okay? So the first thing I'm going to do is I'm going to write a little program for you in source code, which is called C. Okay, this is the language that I will actually execute the program, and I have to get into a text editor, and so this VI just basically says, start editing this file called hello.c, and I'm just going to type a little program here which prints out hello world. And so the first line I have to use is include standardio.h, like that. Whoops, standardio.h, like this. And you look at that and you go, well, that's English, but what does that do? Okay, well, the standard IO you might not know, but include, what include means. So, you really, don't know what's going on here, but, it's at least humanly readable. And, well, let me continue. Int main, like this. And I'm just going to go printf, and then in quotes here, hello, CSC 110 class. And I'll put an exclamation point like that, okay? And at this point, you're going, wow, like that kind of looks like English, but that doesn't say print. It says printf, whatever that means. The hello CSC 110, that's just a string. We'll edit that in a minute, okay? And then I got to add a little bit more, return 0 like that, and then I can close off this curly bracket, okay? There you go. There's source code, okay? And the source code, looking at it like that, you don't know this programming language called C, and I don't expect you to learn it, okay? So don't worry about the details. Just kind of understand what's going on here. This programming language called C, it has a series of commands inside of it that do things, okay? And I know C very well. I program in it all the time. And basically, I know that I have to do this include standardio.h and blah, 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 so that I can print out hello CSC 110 class, okay? So I just created a little app, all right? And now if I do ls again, you'll see that it's listed there. There it is, okay? On that line right there, all right? And you say, okay, great. Well, have the computer execute, or execute just means carry out the tasks that are in that hello.c. And to do that, you would do this, except that it goes permission denied, which is basically the computer saying to me, I have no idea what this thing is, okay? It doesn't even know what to do with it. And that's because this hello.c is the source code. What I'm highlighting right now is purely source code. It's for me to read, okay, but not for the computer to execute directly. I can convert the source code into something that the computer can execute, okay? And this command that I'm typing right now, gcc -o hello.c, like that, basically what this piece does here, it says, well, take that source code and convert it into an executable. And all that executable means is that it's code that the computer can actually, it's the actual app. Okay, it's actual code that the computer can run. And if I do this ls again, you'll see now I have two files listed. I have a file hello.c, that was the source code, and then I have this file called hello. Okay, and now I can execute hello, and guess what it does? It says hello CSC 110 class. Oh, sorry, 100 class. Well, you know what? I'm glad I made that mistake, because now I get to fix my mistake. Okay, so I said CSC 100, it should have been CSC 110. Well, I can't fix it by going into the application, okay, because that's not what the human interacts with. The human interacts with this hello.c, but I can go back into hello.c here, okay? So I'm in my editor right now. This is like just a text editor. This is just plain old ASCII here, and I can just move my cursor over to, that CSC 100 and fix it to CSC 110 like that. And then I can save it like that. And now I recompile it. Compiling means just converting it again into an executable. Okay. And then I run it again. And now you could see that it's corrected and it says hello CSC 110 class. Okay, and you know what, let me clear the screen because it's getting a little bit cluttered. I can go back in there and I can change it to I don't know, let me just get rid of all this and say, what do you think of this source code? Okay, and you may not know what to think of it, but you can see that what I'm doing, I got to convert it again into an executable. You can see what I'm doing is basically I'm just creating a tiny little app, and all this app does is it just prints to the screen whatever I tell it to print to the screen. Okay, and that's enough for you to understand source code. Okay, now why was this distinction important? Like, why did I need you to understand this source code? Because we're talking about how software is developed, and it's developed in terms of this source code here. Okay, that's what humans interact with when we write the application, but the computer interacts with just the hello, okay, which is called the executable, or you could think of it as just the app. Now, suppose for some reason all I gave you was just the app, but I didn't give you the source code. You say, could you figure out from the app, just the executable, could you figure out what this thing does without running it? Like, could you look inside of it and figure out what it does? Unfortunately, it's not that easy to figure out, what's inside of hello.world. There are techniques for doing it, but let me just show you right now. If I try to do a text editor, okay, so I'm trying to look at the hello like that in this text editor, and you get this, and you look at this and you go, well, where's the hello world part of this? Like, where's any of the stuff that it does? Like, if you look at the top there, it says elf, okay, and you're wondering what's an elf, okay, like, isn't that a mythical creature? Well, it actually does mean something, but like, most of this is just gobbledygook. Okay, in fact, you probably can't even see where the there's no place in here where you can, maybe if we scroll down, I don't know, I'm trying to just see if there's a place where you can see the CSE 110. I don't think there is. Yeah, you see, it's just not that easy to go from the executable back to the source code. It's easy to go from the source code to the executable, but not from the executable back to the source code. Okay, so that little demonstration was just, again, to show you this is what the developers work with. They work with the source code, okay? And then they convert it into the executable, that is the application itself, and that's what we give you, okay? You get that application. Now, I showed you all that, and you go, well, so what? All right, why is that important? Well, here's why it's important, okay? There's two models by which software is developed, okay? So the first model is known as the proprietary model. Okay, so this is just like the sort of the business model for how we do the business of actually software development. Because software development is usually not done by one isolated person. Just one isolated person is not able to do a lot. Okay, this is usually large team efforts. Okay, and so the proprietary model, that's basically a company. So there's a company like Microsoft. Okay, Microsoft is a software company. They don't get into the business of hardware, and what this company does is it basically hires developers. Okay, and a developer is someone who writes source code. Okay, and these developers, they write the source code, but the source code is not shared. Okay, now that's important. Keep that in mind, that the source code is not shared. The source code is kept secret. And actually, the software developers, I say here, sworn to secrecy. What it is, it's actually called a non-disclosure clause. And what it means is you're not allowed to, as a software developer, you're not allowed to talk about how that software is done. And when I've worked for software development companies, then they asked me to write a non-disclosure clause, because that makes sense. They own the software, they own the source code. They don't want me to tell their competitors how that source code works. Okay, that makes total sense. All right, now you don't. As a result, because that software isn't public, only the developers have it. Okay, you as the user doesn't get to see the software, and other developers that are outside of the company, they don't get to see the software. The software is secret, and so, for instance, you don't know if, for some reason, there might be something inside of that software that does some spying on you. Okay. Now I put spying in quotes because it might actually be part of that the EULA, as it's called, the end user license. When you have to click on, like, do you accept the terms of the use of this software? Well, in there it might say, well, we get to use your data for something, for some analytics or for some marketing or something like that. And first, you probably won't even see it. Okay. Secondly, they always put it in this nice way, like, we're gonna spy on you, but we're gonna tell you that it's just for marketing reasons or whatever. Okay. And if that's in that software, and you agree to it, you really can't see it. You don't know exactly what's going on. Again, I don't want to make you paranoid, because they're these companies, they are under some auditing pressure, so they can't just get away with anything. Okay. And then there are other ways to see that you're being spied on, so it's not quite as easy as that. But basically, because the source code is hidden, it's secret, people don't know exactly how that software works, and that is a reason to worry about it. Okay. And the software, the other thing is that the software is written by a company, and the company has to pay these developers. And so, the company can't hire a lot of people. It's only going to hire so many developers. And so the amount of brain power that goes into developing the software is a bit restricted. Okay. Like, you can't hire thousands of developers. You might be able to hire 100 developers. Even that's a huge team. I don't think I've ever worked in a team with more than like 6 or 7. I can't remember right now because it fluctuated in size, but maybe 6 or 7 people as part of a team. So I was part of small development teams. I was never part of a really large development team in proprietary. Okay, for open source that's different. Okay, so that, again, because you got to pay all these people, and so there's not as much brain power in developing the software as you might think. Okay, and so this is the proprietary model. Okay, you as the end user, what do you get? You get only the application, not the source code, because that's secret. You only get the application. Okay, and you don't even own the application. You just get a license to use it. All right, and so you say, well, what's an example of this? Well, an example is Windows 10, like that's the operating system. Okay, you do not own, if you've got a Windows machine, okay, you do not own that operating system. You have a license to use it on your laptop or desktop, but you don't actually own it. Okay, you couldn't sell it to someone else. Okay, like if you own a car, it's your car. You could sell it to someone else, but you don't own Windows 10. You can't sell Windows 10 to someone else. Okay, or another example, of course, now that's an operating system. Another example would be Microsoft Word. Okay, so those are examples of software which are designed by within this proprietary model. Now, this may seem like the only possible model. You go, well, how else would you develop software? Okay, and here's where it gets really interesting. The other model is open source. All right. Now, open source kind of confuses people because they say, well, why would anyone want to develop in this model? Okay, so let me describe the model first and worry about why there's business incentives to use this model later. Okay, let's just take a look at how this model works, and then I'll demonstrate. I'll actually do a little bit of software development for you in the open source model. Okay, so this software is not owned by anyone. Okay, your name is attached to it as the person who contributed it, but it's not like it belongs to someone. Okay, and it's freely distributed on the internet. Okay, anyone can take this source code off the internet. All right. Now, this word free is an interesting word because this software is free in two senses of the word. Okay. It's free in the sense that you don't have to pay for it. All right. So, for instance, like when you get your a brand new computer, okay, it probably doesn't come with Firefox, okay, or Chrome. All right. And you might say to yourself, well, I kind of like Firefox. I want that browser. All right. Or there's like lots of browsers out there. You go, well, I want Firefox. You say, well, how do you get Firefox? Well, you go to the mozilla.org webpage and you download Firefox and you install it. And how much money did you pay for that? Zero. You didn't pay anything for Firefox. And you go, well, how could they possibly pay all these developers to develop Firefox and then give it away for free? How do they make their money? Hang on. That's why this is kind of a weird model. And you wonder, why are people doing this at all? Because it's free. Okay, like literally you wonder where the money is. Okay, and people dedicate a lot of time to developing this software, so there is money there. It's just not in the actual sale of or licensing of the software as it is in the proprietary model. Okay, and like most of the apps that you get off of the Google Play Store, or the Apple Store, they're free. Now, some of them you do have to pay like $1 or something like that. but they're pretty much free. Okay, and so you go, wow, how is it possible for all this stuff to be free? Okay, that's one sense of the word, free. You don't pay for it, but it's free in another sense, and this is actually the more important sense. Okay, even if you paid for it, this other part of free is important. Okay, it's free in the sense that anyone can examine the source code. Okay, so it's free in the sense of free speech. It's open. Anyone can see that source code. And I think now you can understand why, because if all you've got is the app, it's very hard, even for a seasoned developer, to figure out what that app is doing on the inside. Is it stealing your information? Where's your information going with it? How does it work in its internals? Okay, I've heard this analogy online, and it kind of makes sense. It's kind of like buying a car where you can't open up the hood. You don't get to look under the hood of proprietary software. You don't get to see how it works on the inside, and so that makes you feel a little bit uneasy because it's dealing with all your information. Okay, with open source code, you get to see the source code. Okay, in fact, that's part of the kind of the agreement that goes along with open source, is that it's not only is it the source code freely available, but it must remain freely available. Anyone that wants to see it gets to see it. Now, you're not developers, and you just saw that hello.c world. You say like, well, I don't know, I wouldn't be able to look at that, but I can. Okay, even if I didn't develop the code, I can look at it and I can go, oh, I don't know what about this. Like, where's this information going? Okay, and stuff like that. All right. So yeah, the second sense of free and the sense of free speech are like openly available, so you can see how this software works. That's important. Okay, and so basically uh, uh, in the open source model, there are no secrets. Okay, to how the source code, how the application works. Okay, and it's hard for you to develop software that spies on you. Okay, now I have actually seen that, but and it might last for a little while, that someone put something fishy inside of some code. But you know what? Sooner or later, people notice it because they go, wait a sec, someone will look. Okay, because developers are looking at one another's code all the time, and someone will go, what is this thing in here? Why didn't someone notice this before? Okay, and I think like the longest I've ever seen is maybe a month where someone, in some obscure piece of software, someone didn't notice that there was a little bit of spyware in there. Okay, and as soon as that was discovered, that whole team was discredited, and it was just it was terrible for them as developers. Probably if you were part of that team, you might never have been able to develop again, because who would trust you after that, right? So anyhow, this is kind of important stuff. All right, so yeah, so it's there, and it's openly available. And the other thing is, remember, with the proprietary, you have to pay these developers. Okay, and you're going to be paying these developers, so you can't have a lot of them. You can only have like maybe 10, unless you're a really huge company. Okay, and with 10 brains, you can do a lot, but you can't do as much as you can with hundreds of brains or thousands of brains. And so with open source, not only is it that everyone could look at the source code, but anyone can contribute to the source code. Okay, so I'll show you that I've actually contributed to the Tor project. So you remember the Tor browser. Every time you use the Tor browser, you actually are using a little bit of my code in there. Okay, now it's very, very little. It's not a lot. I noticed some problems in Tor when I was using it in the source code, when I was reading through the source code, and I said to the developers, I know the developers. Okay, like Roger Dingledine is the guy who developed it. I met online. I've never been physically in person, but I've spoken to him once. But the guy who I've spoken to more was Nick. Okay, but I haven't done that much development with Tor recently. But I knew who these people were. I knew who these developers were. Okay, and I noticed some problems, and so what I did was I fixed the problems. I submitted what's called a patch, a fix to them. They reviewed the patch, and then they incorporated it into the project. Okay, and so anyone can look at the code, and anyone can contribute to it, make it, improve it, and make it better. Okay, and so now you don't have just a few minds that you have to pay. You have lots of minds, because there are lots of people that are looking at this source code, and there are lots of people that are trying to make sense of what's going on. If someone notices a problem, they'll point it out. They'll submit a patch to the developers. The developers will review it, and if it makes sense, they'll incorporate it into their source code. You have projects, open source projects with hundreds, maybe even thousands of like the Linux kernel. There's thousands of developers that contribute to it every day. Like it's just enormous. Okay, so the amount of brain power that goes into it is huge. And you know what that means? That actually means that open source, even though it's free, okay, that you don't have to pay for it, actually is better in terms of its quality than the proprietary model for exactly the reason I just said to you. Again, at this point, you're going to be totally confused as to why this free software, like free in terms of you don't have to pay for it, is better than the stuff that you have to pay for, because that's the opposite of how we usually think of things. If I were giving something away for free, you go, well, what's wrong with it? Like I said to you, I'm going to give you my car for free. You're going to go, well, wait, why are you giving away your car for free? That makes no sense. Okay, but hang on, I'll get to the economics of this later. Okay, I'm going to demonstrate for you a little bit of this open source development for you before I move on. Okay, and so a Gentoo Linux, I'm a Gentoo Linux developer. It's an operating system, so I work on operating systems, not so much on applications. Okay, so and I work within the Gentoo Linux team. Okay, and that's an example of open source. Ubuntu is open source as well. I wouldn't recommend, if anyone wants to play with Linux, like if you want to play with Linux in VirtualBox or something like that, I don't know if anyone wants to try. Don't use Gentoo. It's really not for like people who are new to this stuff. Ubuntu is great though. Okay, and then like the Tor browser, and then for the rest of the course, we're actually going to be using a program called Libreoffice. I'll tell you about that later. But it's also open source. Okay, so you'll be surprised that Canvas is open source. Okay, so that entire web page, when you go in there and you're working on those your courses in Canvas, you're actually working on open source software. Okay, and I'll also show you my contributions to torproject.org. That's my contributions to Tor project. Now I should explain with the Tor project, because I'm not a Tor developer, I can contribute to the project, but it's got to get reviewed. In other words, someone who really understands the internals of Tor reviews my fix to their source code and then incorporates it. Okay, so I'm not going to be able to actually do a direct commit. A commit means like I actually put the code directly in. Okay, and I don't have any fixes for Tor anyhow. I haven't looked at that code in years, to be quite honest. Okay, but I can with Gentoo. Okay, and I've got something prepared for you. So I'm actually going to demonstrate for you a commit to the Gentoo source code. Okay, so let's take a look at that. So let's go over here, and you wonder, what am I looking at? Okay, so you're looking at a web page, and this web page is I don't know if you can see that highlighted. No, not too easily, but it's you take a look at the URL up here. It says https github.com. GitHub is basically a site where it's a web page, but it's got like the source code for many open source projects. Okay, and then it says infrastructure, and that's the instructor. Okay, Instructure is the name of the company that does Canvas, and then you see here it says canvas.lms. Okay, it's in the URL here, but I think you can see it better there. It says canvas.lms. LMS just stands for Learning Management System. Okay, there are other LMSs like Moodle's another one. The college used to use Moodle. Another one's called Blackboard. If you go to other colleges, they might use different ones. They're all more or less the same. And here it is. Here's Canvas. And so you can look through here. And I mean, I know you're not a developer and you probably never will do any development, but what you're looking at here are all the different files that go into making a Canvas site work. Okay, and it even says here Canvas, and Canvas is a modern open source LMS, learning management system, run by Instructure Inc. Okay, so that's the company that sponsors it. That a company might sponsor an open source project, okay, but the company doesn't own the code. The code is open. Anyone can make use of this code. Anyone can contribute to it, and so on. And so you know what? Let me show you all the contributions to it. Okay, I haven't looked through this before the lecture, so I'm kind of looking at the same time that with you guys as I lecture here. Okay, and so what we're seeing here is like here was a commit that was made, and then there was another one beneath it. Each line here is a commit. Okay, and so like make discussion pagination spec friendly. Okay, things like that. Okay, again, you wouldn't understand what any of this means, and that's okay. I don't expect you to, but each one of those are little tiny improvements that have been made by individuals. Okay, I don't know who any of these people are because I just don't know this team, but this Math S22, that's a person. Okay, that's his kind of a nickname or a username, okay? And this person made this commit right here, okay? So we could just take a quick look at it, and you could see, you know, the green was the stuff that was added, and there you see the green there. The red was the stuff that was removed from the code. And so you could see that they're adding and removing code. And, you know, you take a look at the source code. So we usually don't call it source code, we just call it code for short. And you can see here, next unless value dot blah, 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 blah. And it's in this kind of English where, you know, you really can't understand it if you don't know the programming language, but it's English-ish, okay? That's not what the computer actually can run directly. It's got to be converted into that source code, okay? And there you go, okay? So, and so on and so forth, all right? Let me show you next the Tor source code. So here's Tor. You can see their icon up there. And what we're actually looking at now is the commit history here. Okay, so it's a little bit small, but each one of these lines, each row here, is basically another little improvement. All right, and I know it's kind of small, but over here in this little search bar to the side here, right there, I can actually search for my name. Okay, so I can go over here to author, and I can just type in my last name, Basile, like that, and I go search. And what you see there are my commits, and you can see there my name, Anthony G. Basile. And it looks like my first contribution was in 2012, and then I made some contributions in 2014 and 2015. This is really very little, okay? I'm just trying to show you that, you know, I'm not a Tor developer. I looked at the code, I noticed some problems, and I sent them off, and they were, you know, adopted. Okay, so let's take a look at my last commit here to Tor. See, this was very tiny. Okay, it was a very tiny little mistake. Okay, and they had this what's in the red there, and I improved it to making it the green there. Okay, we'll take a look at maybe another one here. I think this one was a little bit bigger. No, that one's a tiny one too. You see, they're just small errors because, you know, to be honest, I'm not a Tor developer, so I don't know how it works. Since this one was a bit bigger, I remember this one. Okay, so you can see here the red was like I removed, and then I added the green. Okay, and there you go. Okay, so how did my commits get in there? How did my patches get in there? Well, I you know, fixed it, and then I emailed Nick, who is the developer, and the lead developer, and he, you know, made a judgment about it and then incorporated it. Okay, so I do have a direct commit to this repository here, which we'll look at in a minute. This is the Gentoo repository. Okay, the repository of the source code is called the repository. Okay, so we'll look at that in a minute. Actually, you can see a couple of my commits from earlier today. You can see where I say my name is there, Anthony G. Basile. Okay, so like about a couple of hours ago, or it looks like an hour ago, a little over an hour ago, I made a couple of commits. Okay, actually, let me, if I refresh the page, it was probably longer than that. Yeah, it was longer than that. Okay, I just didn't refresh the page. Okay, not that it makes that much difference, but let me just show you a little bit of that cycle by which you know, improvements are made. So what you're looking at here is basically a bug report. Okay, so there was a bug in this application called IPv6 calc, and you now know what IPv6 is. Okay, so this was a program that had to do with like doing calculations with IPv6 network addresses. Okay, you can see that this has been resolved. All right, I actually resolved this earlier today, this bug. So someone tells me, hey, look, there's a problem. There's a problem in this code. Okay, and then this other developer, you know, says, yeah, here's the problem right here. Okay, and then later I look at that and I go, yeah, it's a problem. Okay, you can see my comment there. I say that sucks, and then I explain, you know, that this is a problem. And then you can see over here, I actually, this is where it says this bug has been closed and it was fixed. Okay, and here's the fix right there. If you click on that, it shows basically, you could see the green and the red there are pieces of code that I removed. The red is what I removed, and the green is what I've added. Okay, and so there you could see an example of the source code being improved. Okay, I don't want to belabor this too much, but why don't I just do this? I'm going to show you now how such a commit is made. Okay, and it appears in the repository. So if I go back to here, and we switch to this other window here, you can see here NetMISC IPv6 calc. Okay, so I've already made some changes here. So there's some files. I've already made changes to this file here that I want to include in the open source repository. Okay, and those changes I can actually do git git show or git diff like that. Git diff head. I forgot what status I left this in. Okay, there we go. And you can see here that the stuff in green is what I've added to the code. Okay, and the stuff in red there is what I've removed, and the stuff in green is what I've added, and so on. Okay, and before I actually commit this, now I tested this already, but before you actually commit something, you don't want to put something out publicly that is broken. Okay, so what I'm going to do next is I'm going to do that compiling. Okay, I'm going to basically compile this into executable code, okay, to make sure that it works. And clean install like that. And this might take just a second. But what it's doing right now is it's basically converting the source code into the executable. And so I'm making sure that, when I put the source code out there, that it'll actually work for other people. So I assume that if it worked for me, that I was able to convert the source code into executable, if it worked for me, it should work for other people. Okay, so it looks like it's ready to go. So what I'm going to do here is I'm going to prepare it to be pushed out. Repo man commit. Okay, and someone earlier, not as a bug report, but just in a chat room that I sit in, suggested that I make this change because it's nicer. So I'm just going to say, use bash arrays, use this other technique because it's nicer. Okay. All right. So here I'm actually going to put in a little message for what I'm doing, and convert to bash arrays. Okay. Better say convert econf arguments. Okay, so again, I know you don't know what that means, but that means something to other developers. Okay, to not bash arrays, to a bash array, args to a bash array. Okay, that looks good. Let me just read it to make sure I'm doing this right. Convert econf args to a bash array. Looks good. Okay, what I just did there was I just signed it with my public key, okay, or my private key, I should say. And you remember the private public keys? Well, they can be used for lots of things, and so now basically I put my little signature on it, okay. And then the next thing I'm going to do is I'm going to push it to the mirrors, to the repository, not the mirrors, okay. And there it goes. It's being pushed up, and hopefully this will succeed. Like, I'm doing this live, so I haven't tested it. And there you go. It's now should be on the mirror. So now if we switch back to this, to the repository, you'll see here, like these last author, like Sam James. I know Sam. Okay. And if I refresh this page, it should show up there. There it is. Okay. Take a look at that very top line. It says Anthony G. Basile. It says NetMISC IPv6 calc, convert econf args to bash array. And if I click on that, all right, you could see the green there. That's, what I've added, and then the red is what I removed, and so on. Okay, so well, that's it. Okay, I just wanted you to actually see how developers, open source developers, will actually make changes to their code. Okay, I made the changes earlier today. Okay, I wanted to make sure they worked before I pushed it. But I made the changes to the code, and it was local on my machine here, on my computer here, and I put it up on this web page, this Git repository, and now the whole world gets my fix. Okay, and so all of these developers, hundreds of them, are just contributing all the time to this open source code, and it makes it better and better and better. Okay, thousands of minds contributing to thousands of projects, and that's why open source is good, and it's free. When I did that, I made my work available to everyone. I made it available for free. It's not like I got any money for that. All right, so now that you understand all that, you might say, why in the world would anyone do this for free? Like why would you ever just give away your work for free? Okay, and it is a little hard to understand, but let me see if I can explain it to you using piracy as an example. So what is piracy? Like when we say, you pirate something on the internet. What is that? Well, piracy, usually pirates use BitTorrent, okay, to exchange their files. And I'm not advocating piracy. I'm just trying to describe how it works. And what people will do that are pirates, like someone will have a movie, say, and they'll take this movie, and no one else has this movie. And what they'll do is they'll start up a BitTorrent seeder going, and this BitTorrent seeder will seed out to other clients. Okay, and you go, well, why did they just do that? Well, the reason they did that is not because they got anything out of sharing out their file, but in anticipation that other people out there will also share their files in response. Because if I'm sharing out my stuff freely, maybe other people will share out their movies freely. And there's a saying in the piracy community, it's sharing is caring. And so if I'm sharing my movie with everyone, you share your movies, and everyone will share their movies, and before you know it, everyone's sharing movies, and we have all these movies for free. Now, the movie companies don't like that, okay? And so they've tried to stop that, but I think they know they're fighting a losing battle, all right? But again, that's getting a little bit far afield. It's this idea of sharing is caring, okay? And that doesn't just happen in the piracy community. That happens in a lot of things online, and that's what open source, at least how it began. Open source began in the late 80s, early 90s. This was like when the internet was really in its infancy. Like people didn't even know what the internet was at that time. And mostly the internet was being used by just engineers and mathematicians and physicists. My PhD is in theoretical physics, although I moved into software engineering. And what we did was we would just make our code available to other people, okay, and then they would make their code available to us, and we would look at one another's code, and that's how we learned, okay, and that's how we shared, and we helped one another out that way, okay. And so this repository of code got bigger and bigger and bigger and bigger and bigger, okay, and by the time you're like into the early 2000s, there's so much code out there that you can build like entire operating systems out of this, okay. They weren't anywhere near as good as they are now, but you could build operating systems out of it. And then companies like IBM, they go, maybe we better get into this business of open source development. And you say, well, why would a company like IBM want to ever do this? Because they're a company. Why don't they go with the proprietary model? Well, here's why. IBM is in the business of making hardware, not software. But you can't sell a computer that's just hardware. Okay, if you sell a computer that's just hardware, it doesn't work. It needs the software. So IBM had to partner with a software company like Microsoft. All right. So basically, they have a kind of an agreement. Okay, and I really don't know where IBM is today, but like Dell has an agreement with Microsoft. Dell says, we'll make the computers. We'll make the hardware, I should say. We'll make the hardware. You put the software on it, and then we'll split the profits. Okay. Well, you can imagine what happens when two companies get together. They'll argue about who gets more profits. Okay, so IBM says, well, you can't possibly run our computers without the hardware, so we get most of the profits. And then Microsoft will say, well, you can't possibly run a computer without our software, so we get most of the profits. And you can imagine that this kind of breaks down. IBM actually tried to write their own software called OS2. It was a disaster. And so IBM says, you know what? Maybe we can tap into this open source thing. Okay, so maybe we could start doing the open source stuff. And so in the early days, IBM started to actually sponsor really heavy developers of open source. Basically, they said, you know what, you Linux developers, mostly this was the Linux kernel. You Linux kernel developers. The Linux kernel is as the word kernel suggests, it's the deepest part of the operating system. Okay, you Linux kernel developers, here's some money. Develop code and give it away for free. Okay, and then not only did they give it away for free, but this encouraged other people to also contribute, people that weren't being subsidized by IBM. Like I have a little bit of my code in the Linux kernel as well. So it incentivizes people like me to contribute, okay? Because I simultaneously get from that community as well as giving back, okay? And so this is kind of like piracy, but in reverse. I give to the community, they give back to me, all right? I have wonderful software on my computers, and I paid nothing for it. I mean, like for the software, okay? Absolutely nothing for the software. When I haven't bought a computer in a long time, and I think the last computer I bought, 2013 or something like that, 2014. I put it together. I just bought the components, put it together. No operating system. I put Linux on it. $0. Okay. I loaded it up with all sorts of open source software, that does more than I can possibly ever want, all free. Okay, so I get software and I contribute back. Okay, now the Android phones, the operating system is also mostly open source. Okay, it's open source as well. And you say, well, but I'm not a developer. That's okay, because you're just kind of like the fallout. If developers are giving source code to one another left and right, well, then why not give it to people that even don't develop? And then there's other things that people contribute to open source beyond that. They contribute like artwork, like every little, like even the little icons in some application when you have to press a button, someone had to draw that. Okay, now that person might not be a coder, they may not be a software developer, but someone's got to draw that. I don't like to draw things like that. Someone else draws that for me, great, I'll incorporate it into my program. Okay, and so I'll write the source code to make use of that little picture that someone drew for the buttons in my application. Okay, and this has been going on for years. Okay, most software out there right now has some open source backing to it. Now, you can have it mostly open source and then a little bit of proprietary on top of it, okay, and something like that, okay, like most commercial, like Android has a little bit of commercial stuff in it, but it's mostly open source. And this is nice for you guys because mostly because this open part of it, not just that it's free, but that it's something that everyone knows what goes into it. Okay, and there's a lot of bad things that happen with if the software were purely proprietary, a lot of bad things would happen. Last thing I'll tell you, and then it'll be the end of the lecture, and that is like Europe, for instance, had a choice. I don't remember now if it was the French government or the German police or something like that. They had a choice whether to go with Microsoft, like Microsoft Office Suite, for like their files and everything like that, and for their operating system, versus open source, okay, like Ubuntu Linux and Libreoffice. Okay, they chose the open source, and here's why they chose open source. And then they actually contributed money back to those projects. You see, the reason they chose the open source is because they're worried that if they put all of their files and all of their information so that it only works on Microsoft products, well, Microsoft this year will charge so much money for their software, but once you're totally invested, then next year they will charge more. And what are you going to do? Back out? Then you got to convert everything over, and that's a lot of work. And then next year they'll, as you're more and more invested, they'll charge more and more and more because they can get away with it. This is known in the business as data lock-in. Okay, and you can imagine having like a file, like a Word file. It's your thesis. You've been working on this forever. Okay, and luckily this isn't true. You can open up a Word file in LibreOffice in open source, but imagine that you could only open up your thesis in Microsoft Word, and you have to spend $1,000 now for a Microsoft Word to open up your thesis. Okay, and you go, well, this is terrible because last year's Microsoft Word, for instance, doesn't work anymore. I don't know, they pulled a switch on it or something. Okay, these companies, they'll do whatever they can to get away with stuff. So now you got to spend $1,000. Otherwise, you lose all of that information that you put into your thesis. Well, you would probably pay it. It'd be very annoying. You'd be very angry at the company, but if they can get away with it, they would. Well, they can't get away with it, okay? But this is the idea of data lock-in. And with open source, data lock-in is practically impossible because everyone knows how it works. And even if someone said, well, you know what, we're not going to develop LibreOffice anymore. Some developer will come up with the desire, the need to continue opening up their LibreOffice files. Okay, so where we're going to go next is we're actually going to be studying Office software. Okay, and I don't want to study one particular suite. Okay, that is a series of programs. Suite is like a series of programs that work together, and Office means for the office. So I don't want to just like be stuck on Microsoft Word and Excel. We're going to study word processors in general. We're going to study spreadsheets in general, and even though I use LibreOffice, which is an open source Office suite, and I'll show you that in the next lecture. Okay, you if you've got Microsoft Word and Excel, you can certainly go ahead and continue using those. These are all interoperable with one another. But a nice example, if you don't have like Microsoft Office and you don't have Excel or anything like that, and you say, I want this for free, okay, you don't have to go out and buy it. You could just download Libreoffice. Okay, and Libreoffice is the open source version that's meant to compete with Microsoft Word, Excel, and so on. Okay, so I'm getting a little bit into the next lecture, but I thought it was important that I should give you some idea of this software world that you're in. Okay, so that you know, well, two things: the danger of proprietary software, because you don't know what it's doing, you don't necessarily know what's happening in the internals of the program, what it's doing with your information, how it's making use of it for marketing. It might be innocent, it might be less than innocent, and so on. Okay, and versus the open source. Okay, and there you go. Okay, so next lecture we'll be looking at LibreOffice. Actually, for the rest of the course, we'll be looking at LibreOffice, and we'll be looking at the various programs that make up the suite of programs that are used in an office. Okay, bye-bye.